Hello, hello, hello. We're talking about special sequences today. Not typical sequences, but special sequences. These sequences sometimes have a pattern buried inside the pattern, and it's not always easy to figure out where the pattern is. So in these sequences, we kind of have to dig a little bit. The first example that I want to show you is a square number pattern. And we know what square numbers are. We know that a square number is a number times itself. 1 is a square number because 1 times 1 equals 1. And I encourage you to fill in the rest of these at your leisure. I'm not going to waste time letting you watch my neat penmanship, but it'll follow on and on just like that. Well, these numbers also have a pattern in them, because from 1 to 4, I know that I can add 3 to that. I can add 3 to 1 to get 4. I can also, let me show this to you real quick. I can add 5 to get to 9. I can add 7 to get to 16. I can add to get to 25. I can add, come on now. I can add 11 to get to 36. So we see a pattern inside the pattern. Yeah, those are a bunch of square numbers, but we see that we're adding 3, then 5, then 7, then 9, then 11, and we call all of these consecutive odd numbers. So I can keep following this pattern out and keep finding all of these square numbers in a specified, set. And if you look even closer, how do I get from 3 to 5? I'm adding 2. How do I get from 5 to 7? I'm adding 2. How do I get from 7 to 9? I'm adding 2. So I can see that there are patterns, kind of buried inside patterns. What about a triangular number pattern? And I always like to tell people, think about a bowling alley. And I want you to remember that for the next day you come into class. Remember bowling alley, because think about those bowling pins. How many bowling pins are there? There are 10 bowling pins. So keep that in mind, that you see 1 bowling pin, then 2 bowling pins, then 3 bowling pins, then 4 bowling pins. Triangular numbers are basically just a triangular arrangement of dots, and whereby you have 1 at the top and then follows with 1 more at the bottom, 1 more than you had previously at the next lower level, and your bottom row tends to increase every time, so that I have 1 on the bottom, now 2 on the bottom, 3 on the bottom row, 4 on the bottom row, 5 on the bottom row, 6 on the bottom row, and you can keep going as far as you want to. So just adding up all the dots will tell you what your number is. Okay, basically it's almost like not a pyramid, but if you've ever seen the old game show $10,000 Pyramid, they had 3 questions, 2 questions, and then 1 question. So you don't know what I'm talking about. Never mind. So triangular numbers, these are the first in a very long set of triangular numbers, and you can draw the dots to back it up too. So let's show you the next couple here. I didn't drop this one on my head. Congratulations. It has been 1 video since I've dropped a board on my head. What about cube numbers? Now, cube numbers are obtained by multiplying a number times itself. And I took the liberty of writing a few of those out so that you can see that and see why these numbers are cube numbers if you don't have a lot of experience with those yet. But there's still a pattern that can be derived from those too, because I can add 7 to 1 and get 8. From 8 to 27, I could add, what's that? What's that, 19? Just curious here. I've never done this one before, or have I? From 27 to 64, what's 64 minus 27? What is 64 taken from 125? I wonder if there's a pattern there even. I wonder if there's a pattern in the pattern. I want you to bring this to class tomorrow, and I want you to tell me if there's a pattern and if there's something that we can find in there. So this is to be continued. Remind me, because I may forget. I am old. The last one, and I think the most important one, is something called Fibonacci numbers. Fibonacci. No, not Fibonacci, because that would be delicious. Fibonacci. Fibonacci was an Italian mathematician. He came up with an interesting numerical pattern based on a lot of things that you can find in nature. If you think about the whorls of a pine cone, the seeds of a pine cone, someone told me recently dandelions. If you look very closely at the whorls of a dandelion, the seeds and the little flower parts. Also leaves. These are just a few examples of things that exhibit Fibonacci numbers. Why is this important? Well, that's actually a pattern. It's hard to tell, but it actually is. And I wrote down here, and I want you to follow this. It says the sum of the two previous numbers is the next value. So I'm saying add the two numbers before to get the next number. What is 0 plus 1? It's 1. What is 1 plus 1? It's 2. What is 1 plus 2? It's 3. What is 2 plus 3?
Good afternoon, ma'am. Please have
What is 3 plus 5?
Announcements.
It's 8.
This is just a reminder.
You hear the announcements? It's time for me to go. I want you to figure out what are the next 5 values in this pattern, and we'll talk about it in class. Fibonacci is just a very basic addition pattern. Try it out. And have a good day.
Just a reminder, last day will